Welcome to Data Analysis with Python. In this video, we'll be considering data visualization with Plotly. In the previous videos, I think about 4 videos before now, we started talking about all these data visualization tools, their libraries in Python. We started with the most important one. So if you're picking one tool at all in Python, it will be Matplotlib and followed by Matplotlib if you want something more beautiful, doing using having some statistical edge to it, then you go for Seaborn. And afterwards, we went on to look at Plot9, which brings in some R vibes into Python. And afterwards, we looked at Alt-Air. Now, looking at those four we had considered so far, Matplotlib and Seaborn are more like they are good for static plots. Like if you want static plots that you cannot interact with, then if you group Plot9 and Matplotlib and Alt-Air together, they are like the visualization tools that are descriptive in nature. So you have to, it's more like you have to keep adding ingredients and everything. For instance, Plot9 is based on the grammar of graphics, while Altair is based on the Vega Lite grammar or something like that. And of course, in this video, we are looking at Plotly, which is interactive in nature. It's one of after Plotly, we'll be looking at Bokeh. The both of them are really very good for getting interactive plots. When I mean interactive plots, when I say interactive plot, I actually mean plots you can interact with. Like you can hover over it and see values. You can stretch things. You can twist things around, even right on the graph. And because of that, they are very good for instance, Plotly is very good for making dashboards. And after this video, I'll be talking about making dashboards with Plotly. And afterwards, we'll be talking about Bokeh, which is very good for making visuals for maybe for websites or things like that. So, Plotly and Bokeh are very good as interactive uh, tools for data visualization in Python. So, come along as we talk about data visualization with Plotly. Right. So, introduction, Plotly is a powerful Python library used for creating interactive and visually appealing data visualizations. You will agree with me as we go on that, they make very nice plots for sure. So, Plotly is a powerful Python library used for creating interactive and visually appealing data visualizations. It provides a wide range of chart types and customization options to help you effectively present your data. In fact, this will be about the most extensive kind of charts I'll be talking about so far because there are all kinds of things, bubble charts and all of these things, a tree map and all that. Okay, of course, the first thing you want to do if you're installing a library in Python is to do pip install plotly. I have it installed already, but I'll just do it for the sake of those who may be new to this. So pip install plotly now, because I already have it, tells me requirements already satisfied. But if it's not there already, it takes a bit more time. This is what I actually run now. Pip install plotly. Okay. So the next thing we want to do now that Plotly is installed is we want to uh you know okay, the next thing I'm doing is actually to upload the data set. Now I'm using the usual flights, Iris tips, and Titanic data sets from that are built into Seaborn, right? So Seaborn is not the focus here, but Seaborn is just it's more like that vehicle for us to have access to the data set. As you also saw in Altair yesterday, we could actually use the Vega data sets and all that to get several data sets, but I'm using Seaborn in this case. So I'm using the flight, iris, tips, and Titanic data sets. So I have to run this, right? I have to run this to import Seaborn and then to mount all these data sets. So these data sets are available now since you have number two here, but then once we see them one after the other. So let's look at the flight data set. I press Control Enter. So of course we are used to that already. Year, month, and passengers. So it talks about number of passengers flying in an airline or so from 1949 to 1960. Then you have iris, which talks about not the eyes, but flowers this time around. You have three species of iris flowers, Setosa, Virginica, and versicolor, yeah? Then, of course, this is showing us the top five and the last five. So here we have 150 rows and 5 columns. For the flight, we have 144 rows and 3 columns, right? Then for the tips data set, tips is a big deal in America. So Right. So this shows us how much tip people pay as they eat in a particular restaurant. So, and we have seen tips to be proportionate to the total bill, right? Then we also have the Titanic. So this gives information about the Titanic ship that sank in 1912, I think April 1912, right? So it gives where they embarked, the sex of the people on board, their ages, and those who survived and things like that. So that's what the Titanic data set is about. So we visualize that. Okay, so let's go now. Now we have not really mounted. I didn't. So I've not imported any. I've not imported Plotly. So what we are going to do here is that based on what is required for each kind of plot, we are going to be importing Plotly. So for instance, here we want to talk about scatter plots, right? So for scatter plot here, see what we have. So we have to import plotly.express as px. So plotly.express is like the basic plotly you get to use as you do all these things. So import plotly.express as px. That's more like plotly express, x for express, right? So and we want to do scatter plot. So in one of the scatter plot is a very powerful tool for exploratory data analysis, right? So you just plot two numerical things against themselves to see the kind of relationship that exists between them. So here, oh, okay, I forgot to add line numbers for easy reference here, and I have that now. So import plotly.express as px. So here once a scatter plot of tips versus total bill. So how do tips relate to total bill? So we have total bill on the x-axis. We are using the tips data set which we mounted before now. So x on the x-axis we have total bill, on the y-axis we have tip. Then we had coloring according to size. In the tips data set we have something called size, like maybe number of people who attended. I mean maybe a group of two friends, a group of three friends, things like that. That's like size. So that can give us a bit of insight into that idea. So here we have, so all I just run that, and then it brings out the graphic. Okay, I have to, yeah. So this is what it looks like. So you can see total bill on the x-axis, tip on the y-axis. So it means that as total bill increases, tip increases. That makes sense, right? Because tip is it's paid in percentages most of the times, right? Like maybe sometimes you're required to pay to give 10%, 20%, 15% kind of tip. So it increases with how much total bill you pay. So if you see this now, this is like someone who had a total bill of 50.81 and the tip is 10, and a group of three people dined there. So this is why Plotly is said to be interactive. So you can actually point at things and see. So we've seen the biggest total bill is 50.81 and the tip was 10. So which is like that's like 20% of almost 20% of what was done. And here we have a bill of 3.07 and the tip was 1. That's also like six, that's almost like 60%, right? By one person. So you can have, so we have seen the extremes of that, right? So here we are doing okay, now you can see by touching it, I've also changed that, so you can, so I bring it back. So coming here now, we are doing what we did up there was tips versus total bill. So here we are going to do the y-axis, that's width sepal width versus sepal length. Okay, scatter plot of sepal width versus sepal length, right? Sepal length, like this. So same. So so what we did, just like what we did there. So you say fig equals px, that's plotly.express scatter, because we're doing scatter plot. Then the data set we're using is iris. On the x-axis we have sepal length, on the y-axis we have sepal width, and then we are coloring by species, and we title it sepal length versus sepal width. And in the figure, then we show the figure with this. Okay, so see what it looks like. So we see, so it's like so sepal length, of course, as you expect, they are proportionate to themselves. Sepal length increases with sepal width, as you can see for all of the groups, right? But for Virginica species, for instance, the relationship is not that steep, it's not that positive. It's more like very not strong, even if it is positive, right? Like the sepal length and the sepal width are increasing in such a way that it's not really strong, right? So you can move this around and you see maybe for I like to see the very, so the one with the longest sepal length is 5.7 and the sepal width is 4.4. And then what should I check? I can check this. Okay, maybe the lowest here will be this versicolor species, The length is 5 and the width is 2, like that. So we can have all that. Then here again, we have passengers versus year. So scatter plot of passengers versus year. Okay, so I'm trying to take it through different data sets so that we can actually see. So here it's just according to the year, we just move on like that. So for each of the months. Next, we go for the line chart. In this case, we import plotly.graph underscore objects as GO, graph objects now. So here we have line chart of the number of flights per year. So, and before we do that, okay, let me bring the line numbers back. Where is it now? View, yeah, show line numbers. Okay, so in line 6, in line 4, we have flights by year. So, and to do that, we have flights dot group by year and find the sum of passengers for each year, and we reset the index. In line 6, we now have a variable named fig, which is equal to go dot figure. Then in line 7, we have fig dot add trace. So now we have go dot scatter. We are doing a scatter plot, right, of flights per year and I mean year against passengers, right? But then this add trace will help us join the points up with lines because normally scatter plot should just be points, right? But then add trace will join everything up with lines. And then the name is flights. And then we have figure dot update underscore layouts. And the title is number of flights per year with the x-axis and y-axis labeled as necessary year and passengers. So control enter or shift enter, we get this. And you see, like because this is interactive, right? If you point at 1950, you see 1,676 total flew. 1951, 2024, 2024, 1952, 2020, 2000, 2364, 1953, 2700, 1954, 2867, and so on and so forth. So, like that. Now, we can do the same for we can have a line chart of the tip versus total bill from the tips data set. Of course, data set is what makes it different. Here we have the flights. Okay, because we brought in the flights right here, right? But here, since we don't have to do that averaging, so we just have fig equals go on dot figure, and then we have fig dot add trace like before we're adding the lines together. On the x-axis you have total bill, on the y-axis you have tip. You join with lines and the name is tips, and then you just do the title and label the axis here. So we do this and you see this doesn't show any pattern per se, but of course overall it shows a trend like as the total bill increases, tip also increase, which is intuitive for sure, but overall it's just more not here like not exactly like what we got for the previous one. This one is just like a straight line going like that. Okay, now we can have a bar chart also. Bar chart. So in the case of bar chart, we have bar chart of average tips per day. So for tips per day now, you have to group by the day and then find the average of the tip for each day, and you reset index following what we did the other time. And here you have fig is a px, that's a plotted.express dot bar tips per day by day. That is this line 4 is what you are bringing in here. What you have the grouped the average tip per day that you have calculated in line 4, that's what you're bringing here instead of the original tips data set. All right. So X is now day, Y is tip, title is average tips per day. So you can show the figure, and this is it. So it means you have the highest average tip comes on Sundays, followed by I think Saturdays, and then Thursdays I think is slightly higher than Friday, like we saw in previous cases. Okay, here we are doing, so here we did average tips by day. So now we have to have passengers, average passengers per year, right? So average number of passengers, average number, let me just say average passengers. I mean, we get the gist. Average passengers by year, right? So we do the same. So we have passengers per year is flights dot group by year and find the average passengers for each year, and then you do the plotting too like we did before. So we bring passengers per year here as our data set, and then we have the year, the passengers and all that, and then we show that. So this is it. So of course, just like we saw in previous cases too, you have people embracing more and more people embracing flying by as the years went by. So that by 1960, it's almost like triple or double of what happened in the number of people that flew in 1949 when the whole thing started. So in 1949, we had 126.667 passengers average, but by 1960, here we had 126, right? Let's say 127, and here it's 476, a bit over double or something like that. Okay, so we can also do pie charts, can go for pie charts. So we want to calculate the total tips per day, total tips per day with observed true to silence the future warning. So here we are silencing warning here because some things are going to happen. There's an idea called deprecation in Python, right? So maybe you use a particular syntax to do some task currently, but in the future, there are improvements happening every time, right? So then there'll be deprecation. So since it hasn't taken effect, you can have some warning to tell you in the future this thing is not going to happen again. So here we are using observed equals true to silence that warning. So we are using pandas here and plotly.express because of what we might have to do. Uh, where is pandas even used here? The pandas may not be necessary after all because yeah, there's no way pandas is used here. So we could as well do without the pandas. Let me remove it. If you have an error based on that, we can bring it back. All right. So see what is happening. Calculate the total tips per day. We are doing pie charts, right? To calculate the total tips per day. So tips per day is now tips good by day and find the average tip. We have done something like this before. So tips per day will now be tips per day dot sort the values. You sort according to tip in ascending order or descending order if you choose. Okay, in descending order, so that means ascending is false. So you now create an enhanced pie chart, which is like a donut with percentages and labels. So our figure now is now px.py. That's plotly express.py using tips per day. The values it will be the tip, the names will be the day, the title will be total tips per day, and the whole is 0 0.4. So we can have control over the whole by adjusting the 0 0.4. Then you can show percentages on the chart by saying figure.update underscore traces text info equals percent plus label, and then display the chart like we have in line 22 using fig.show. And this is exactly what we have. So this is it right here. That if so on Sundays we have 33.8, on Saturdays we have 35.6, on Thursdays we have 23.5, and on Fridays 7.1% for total tips per day. So this is what we have run. So like I said, if we make this 0.8, what happens? Okay. Yeah, so it becomes thinner. So the smaller, the bigger. So if we have 0.1, we have something thicker, right? So we can adjust all that way. So that's talking about pie chart now, and this is what we run here. And then we can move on. Still talking about pie chart now. So up there we did tips per day. So here we want to do sepal length by species. Sepal length by, or we can say per species if you like, or by species. So here we have sepal length per species. So you have iris dot, so the data set iris group by species and find the average, the total sepal length according to the species. So we are doing sum here. So when we needed average, we did mean, right? Don't forget. So it's also sum here. I think, yeah, we did mean here. So if you want mean, average, you do mean. If you want total, you do sum. Okay. So here we're doing sum. And then following the same kind of thing, we have the sepal length. So you see that, okay, all right. We did not label, uh, let's see. Okay, we should have done the same thing like up here. So let's see. So that is the fig, right? Tips per day, yeah. Value, sepal length, names, it will be the species, and then we have the special sepal length per species. So we should have this. Oh, okay, yeah, because that was hiding. Oh, yeah, I was wondering. So the Virginica is purple, setosa. So you have 37.6% of Virginica, and you have 33.9% for versicolor and 28.6% for setosa, talking about sepal length according to species, right? Then we go to box plot now. I mean, we use box plot a lot, but things get more beautiful when we come here. So imagine we want to do tips by day and time. So tips by day and time. So you have tips. Um, is it tips here? So total bill. You have total bill. Yeah, I think it's total bill, not even tips. It's total bill by day and time. Total bill by day and time. So, so here now we are doing box plot. So it's plotly expressed. So fig is px.box, talking about box plots, and we are using the tips data set. X is day, Y is total bill, color is time. You know the time of day, right? Maybe it's lunch or dinner, and title is tips per day and time. So it's actually total bill by day and time. Total bill by day and time. So we can run this, and then it comes out this beautifully. So here now, on Sundays, everybody comes for dinner. That's what we are saying here. On Sunday, everybody comes for dinner. And this one also gives you the hint about the whole thing. So this line in here is the median, and then the one below here is the lower fence, the lower quartile, and you have the upper quartile here, and so on and so forth. Then you have some outliers here. So outliers right here, not out there. So you have, but on Sunday, people only come for dinner. On Saturdays, people only come for dinner. But on Fridays, people come for both lunch and dinner. On Thursday, few people come for on Thursday, people mostly come for lunch, and only very few people come for dinner. So you can see this gives us more insight than what we had seen with other tools, for visualization. So coming down here, so we want to have so from the Titanic data set now we have box plots of this will now be fare to be the transport fare by embark town by embark town and P class, that's passenger class. Okay. So that's what is happening here. So we do exactly the same. So it's box plot Titanic data set. X axis is the embarked and Y axis is the fare. Color is the class one, two, or three, like first class, economy, and all that in the ship itself. So you see this that for those who came from Southampton, you had most people, you know, with on first class, right, from Southampton, and then you have their fares. So the biggest fares are for first class, of course, as that's intuitive. Then you have third class, and you have second class right here. So for people that came in from Queenstown, they were mostly also their fare was the highest, but then there were just very few, and then you had mostly first class people from Cherbourg also and all that. So that goes. So that's fare by embark town and passenger class. Then we come here also, we can have fare by, we have box plot for fare by embark town and sex, you know, box plot of fare by embark town and sex. So we have the same thing. So here, so for people that came from Southampton, you had uh mostly females from Southampton, interestingly. And then, but of course, you have some outliers paying some very outrageous fares because I think they are mostly in first class, right? And then when you come to Queenstown, I mean, fewer people that were on board from Queenstown, and their fares, you had a few outliers for their distribution. And for Cherbourg, you had mostly females uh, and you had males trying to compete with that factor, but then there you have some outliers also. So, but the spread for female is more, right? That's the idea there. So, I mean, you can see this is giving us better insight into the data set we've been considering. So here we are also doing want to look at box plot for class by embark town and sex. Box plot for class by embark town and sex. So you now have X is embark town, Y is class, color. You are coloring according to sex. So for Southampton, we had mostly females, all right, and they were mostly I mean, they were in all the classes, interestingly. Yeah. For the males, right? They are mostly in first or third class, right? And you have with a few just stretching into second class like this. So for here, you have people mostly in third and first class with a few stretching into second or something like that. So that's happened. Then you have heat map. Of course, you've seen beautiful heat maps, especially started from Seaborn. But here we have heat map again, which is even going to be more beautiful. And then this is to show you that you can have heat maps for maybe just it doesn't have to be. Well, it's usually numeric, right? But the basic idea of heat map is that you have a graduation of the colors, and you have for higher values, you have a particular kind of color. For lower values, you have another kind of color. So for heat map here, we are importing seaborn. Why do we need seaborn here? Oh yeah, because we are bringing the data set, but it doesn't matter because we've loaded the data set up there. So we don't need this seaborn again because we've loaded it already. So there's no point. Pandas also, I don't think we need pandas. Yeah, we don't need it because I'm not seeing any use for pandas there. So we pivot the data for heat map, right? So you have flights dot pivot. So you have flight dot pivot. You want to so it's more like pivoting is more like some kind of grouping. I think we saw this kind of thing for under Seaborn or something like or plot nine. I'm not sure now. It must have been plot nine, yeah. So you are indexing with months and you are using here for columns and values are passengers, and then so plot using plotly. You now have figure equals px.im show. You have flight pivot, the pivot you've done here. Then you have color continuous scale. You use Viridis. Now you can change this. You can use cool warm, rainbow. I particularly like rainbow. I'll change this for you to see what the kind of things we have. Then you are titling it flight heat map, and then you label it using a dictionary. X is Y, year, Y is month, and color is passengers. And then you can update side at the top, and you show this beautiful stuff. So what this is simply telling you is that the yellowest parts, if there's any word like that, the yellowest parts show where you have the highest concentration of passengers. So it means that, of course, as we know, the highest number of passenger was in July, July 1960, 622. When you come down, you also had August 606 passengers in August. So July 1960 had the highest number of passengers. Basically, that's what this is saying. If you also bring it here, so I mean, but as it goes, the darkest you go. In 1949, you had January 1949, you had 112, you know, and then so I think January 1949 was the lowest. So I mean that makes sense because that's what the data has been telling us all along. So heat map does not only give you those numbers, but the graduation of the color actually tells the story. Then we have 3D scatter plots. We've been talking about normal scatter plot, but we can have three-dimensional scatter plots. Imagine that we have 3D scatter plots of tips, total bill, and party size. So we have X is tips, total bill, Y is tip obtained from the tips data set, Z is size from the tips data set. So you have your markers, you have the dictionary size is 5, color is size. Yeah, I was saying that we could change this, right? For instance, I could call this cool warm. Cool warm is one. Cool warm. Does this work here? If it doesn't, then let me make it small letter then. Cool warm. Still doesn't work. What about rainbow? Rainbow. Oh yeah, so rainbow does. Then let's do, I think we can do greens. So this just graduates it in green. So you can see the greenest parts are the place areas where you have the highest number of lights, right? So let me take it back to view this. Yeah, so for scatter plots, you have all of this going too. And then, so you can have this 3D scatter plot. Maybe this doesn't make so much sense if we don't really visualize. So I won't waste time with that. But I mean, just to show you that all these are possible. So you also have this, right? Not making too much sense. So I won't waste time with that. So then we talk about the violin plot. The violin plot. So violin plot basically, what a violin shapes. So that widest part shows you that that's where you have the highest number of distribution. So here we have violin plot of tips by day and sex. I think I should edit something here because this is scatter plot of tips, total bill size, and all that. So it's actually for passengers, passengers year and month, passengers year month. Now, I actually like playing with all these things because as you go on, you definitely some kind of visualizing you are in love with. That's why I like to go through everything as much as possible. So here we have violin plots of tips by day and sex, tip by day and sex. So now violin plot. So you see, we have of course this is also just buttressing the things we've always known. So you have the violin plot, right? So you have Saturday stretching out a little bit more, like you have some outliers there, like that, and then you know, you can visualize all this the way it is. So the widest, so we have the widest on, is it on Sunday now? So this width tells us some story. And interestingly here, once you point your arrow, you can already see some of this information. So it tells you about the median, so you can see what's happening and all that. Okay. So here we have, this should be, did we have up there? It's tip, right? So this is passengers, as usual, passengers by year and month. Passengers by year and month. Okay. See that. Passengers by year and month. So we have this. Okay, I mean this is not looking too sweet. So let's just move on. So this will be sepal length by sepal width by sepal length and species. So this is width, sepal width, sepal width by sepal length and species, like this. Okay, not looking too pretty. So, I mean, of course, we've seen better visualizations for this, so we don't have to waste time with any. So just play around with everything and choose what really works best for you. So here, I want to do bubble chart. Now, this one, this is new. We have not encountered bubble chart in the previous visualizations. So that's one of the highlights of Plotly, right? So here, we want to do bubble chart of flight data. So it's based on scatter plot somewhat. And then we have the flight data set. X is year, Y is passenger, size is passengers, color is month. And then we want to do flight bubble chart. So if you run this is what it looks like. So it's more like scatter plots, but then it's instead of the dots, we have the bubbles, right? So don't forget this. I've been forgetting to expand this, but that's okay. All right. So I do this again. Yeah, because it's interactive, I can just play with it. I can switch, I can shake and all that, and then the values just keep changing. But I mean, you can always rerun to have it back. So that's what uh, interactive plots look like. So here we are doing, okay, we are doing bubble chart of total bill for sure. Bubble chart of total bill from the tips data set. Total bill, total, total bill. Okay. So that's how that goes. So it's more like scatter plots, but then but it's like now in terms of bubbles. Bubble chart of fair is what we are doing here. Okay. So same. So you see the treble guys paid more money, like that, and especially the females, like that. Then we have here we have the so still fair now, but by another categorization. So bubble chart of fair by Embark Town. Fair. So I just say fair still. So same kind of thing. And then we also have here bubble chart of sepal width. Sepal width by sepal length. Okay. This now. So yeah, this is a bit more interesting because we have many data points. So it's more like scatter plots, but with bubbles now. Okay, so we can also talk about stacked bar chart. Stacked bar chart, and here we import plotly.graph underscore object as geo. So we have tips by day and time. So we have tips group by day and time also, and then we have the tip, find the mean, we unstack and do all that. So we have a stacked bar chart. So I mean, this is usually very nice. Like now, this is the future one thing I'm talking about. This tells us that the default observed equals false is deprecated and will be changed to true in the future version of pandas. So past observed equals false to retain current behavior, or observed equals true. So okay, we don't have any observed equals true here. Probably it is some back end kind of thing like that. So I mean, this is stats chart. So yeah, you can compare things side by side. So for lunch and dinner, people do more of lunch on Thursday than dinner, and same for Friday. And for Saturday and Sunday, people do just dinner, no lunch, right? So that's what. So you can compare those two things at the same time. So we can also do start stuff here like that. So these are many, so to speak, and then you can have comparisons year by year for the months. Okay. So, but of course, you can see that everything keeps growing proportionately for each month, year on year, so to speak. Then we have Sambos chart. This is another first. Compare talking about this data visualization tools we've been talking about so far. Again, I think we don't need this because we already have it. What was I thinking when I was putting all this? Yeah, pandas. We don't even need pandas because pandas is not coming up right here anymore. Okay. So here we want to do a sandbox chart. We want to convert month to string to avoid categorical behavior. So we say from the data frame month. Ah, okay. I think I get the gist now. I get why this is necessary now because we are now naming it. So we still don't need pan. Do we need pandas? Yeah, we don't need pandas, I believe. We still don't need pandas. Ah, we will need pandas maybe for this line 9. Okay. So yeah, we are bringing the flight data set and we're calling it DF. So we are bringing the month column and we're making it into a string. We are making it, yeah, we are making it into a string. So to avoid categorical behavior, or we are changing is yeah, month should be date normally, but well, it's becoming like as type string. So we have some bus chart of flights and data. So we have fig equals px dot some bus the data frame, this data frame we just come up with here, and the path is we are categorizing according to year and month, the value of passengers, and then we have this. So this is what a sunbus chart looks like. Okay, so you can point somewhere and then you get. So if you do 1960, it brings something like this. You can click again and it goes back in. So you can do 1959, and it gives proportionate sizes of every part. Let's go back to 1949, for instance. So then you see all the years. So you can point at something and it tells you the values, you know. You come here and it tells you the values and so on and so forth. That's what a sunburst chart looks like. So that's like a first unique to Plotly, or maybe not, but at least we see that here. So we have sunburst chart of tips data. So for tips data, see what we have also. So we have male, total bill for male, we have that. Female, we have total bill. Um, we can then go. So if you click male, so it shows you all the days available. For female, it also shows you yeah what is available. I think proportionately to how much bill they spend. That's some bust chart. So you may want to work with that. So we have something also for yeah, did I change this? Is for tips data set. This is for flights. And then here has to be for species. Uh, that's for petal length, like that. So you also have this, right? So you can have Virginica. Okay, I mean this doesn't have other layers, so we can just point at it to see. So we have petal length 2776, then vesicular setosa. So I mean the proportion you already see tells you the ones with the longest petal length. Then we can have surface plots also. Surface plots. Yeah, I mean you may want to read over this. So you have flights. We are bringing the flight data set again. So you have SNS flight data set. So you have the flight, you group according to the months, then you pivot, and then you do all this so you can have a surface plot. Okay, so another thing is you can rotate this. All right, so but when things get 3D, you need to really understand what's going on to get it. Okay, so that can be rotated around. So we have funnel chart, which is another interesting one. So here we want to do tips percentage. So you want to find the overall percentage of tips, across total bills and all of these things. So we have all this going on here. If you press enter, you see that the highest percentage of tips are paid on Fridays, 15.94%. On Thursdays, we have 15.67. On Sundays we have 15.20 and Saturdays have the lowest tips 14.64%. So if you are so if you I staff working in this place, you may want to go for shifts on Thursdays. Yeah. In fact, you want to go for shifts on Fridays because that's when you get the biggest number of tips. So, I mean, that's a you can. So, if you have the option of choosing a day to work, so you can have data-backed decision like this, right? So that makes a lot of sense. And then this is calculate tips percentages by day. So that's what we've done there. So we can also calculate width as percentage of length and species. So we want to see how that goes. So you have the Setosa have 68.48% of the sepal width, like that. And then you can have a waterfall chart. That's also there are many firsts here as far as Plotly is concerned. So waterfall chart of total bill components by day. So we can do that. I mean, I'm just running through because you have access to the data. So just download everything, download the code sheets so you can play with some of these things. So this is what a waterfall uh chart looks like. So total bill components by day waterfall. So for Sunday, so of course, you have Sunday like that. You have all these other ones. They seem almost the same, but except for little differences. So you have here it's not total bill anymore. It's like sepal length. So waterfall chart of sepal length, sepal length by species, sepal length by species. Okay, we have this. So something like this. Okay, I think I've tampered with it. So you see the trouble with this, it's so interactive, so you can play around with these things. But if you want to get it back, just run it again. All right. So then we also have radar charts. Manifest, interesting, manifests. So for average tips, now you can have radar charts of average tips by day and sex. So try to study this to see how it all goes. So we have radar chart. This is how that works. Maybe it makes sense to someone out there. I don't know, but you have all kinds of things going on here. So again, I have this. Then we can also do radar chart for here. Now it's passengers. It's not pass average passengers, yeah, because we are using mean here. So average passengers by year and month, by year and month, by year and month. So we have this. Okay. Yeah, we have tree map, another interesting thing. So we want to calculate total bill by day and time. Okay. Total bill by day and time. So see what this looks like. Yeah, this is I think I saw like this. It looks like some heat map. And it so if you can use the color bar to see what it means. So the darkest parts have the highest number of total bill. So it's like dinner. Dinner on Saturday has the highest total bill, I think, followed by you have dinner on Sunday. This is 1617. This is 16 like that. So and then lunch has very so when you as you progress like that, it's getting uh not as dark. So that means that the values are depreciating. So this is also some kind of visualization thing you can do. So here we are doing passengers from the flight data set. So you have calculate total. So we want to calculate total passengers, yeah? As total passengers by year and month, by year and month. Okay, so we just do this. Yeah, and this tells you now just so the darkest, the more passengers. So you just go straight to the darkest spot, which is July 1960, like we saw before. And then you have August 1960 also. And by pointing it around, you can see. So like you can have this chart. In fact, this is possible. It's possible to automate this chart that as the years goes by, the data just just rearrange that thing automatically. So you can also have gauge charts, which can be pretty beautiful. So, yeah, I think I've done this. So you want to have chart of the tip percentage. So you want to have the percentage of tip overall, in the whole data set. So you have tip percentage. So that you say tips divided by tip from the tip column from the tips data set all over the total bill from the tips data set. Then you want to find the average of that and multiply by 100. And then you visualize figure is go dot figure, blah, blah, blah. And then you have this. So it brings this beautiful stuff, brings this very beautiful thing. So it tells you that the overall tip in the whole data set is 16.808%. So as a customer, this can help you that when you're going to that particular canteen, a particular eatery or whatever, you should be ready to pay a tip of at about 16% or so. So that can help you to get ready. Okay. You can also have a scatter matrix plot. So we are doing this now to the scatter matrix plot of tips data set. All right. So we just have this. So it shows you different things. You have box plots, you have like scatter plots, you have everything joined together. So yeah. So did we say tips here? No, it should not be for tips. It's actually uh flights data. Flights data like that. So you have all the months. So interesting. You can have all that. So for the tips data, it is still flight, right? So you still have flight here. Scatter matrix of still the flight data. Yeah, flights data. So it brings in more things, right? So you can have distribution. So like these are very sweet stuff. So you have something about the month, about the passengers, and all that in different formats. So you can also do it in another dimension. So you can always choose what actually works for you. All right. Now we come to that point where we want to learn about how do we save in Plotly. So one beautiful thing is you can save in Plotly in different ways. Plotly is not like Seaborn and Matplotlib that are static, like you can just copy save fig. So this one has its own special way. In fact, there's a way to save static images. In that case, you need another you need to install another library, which it was problematic trying to get it up. So I didn't bother about it because there's a very simple way to save, which I'm going to explain shortly. So you can save manually from the browser, right? If you just display the figure in Jupyter Notebook or another interactive environment, you can click the download plot as PNG button in the toolbar. For instance, if you run this, we've seen this before. It's a tree map. So for this tree map now, instead of worrying about how to save anything special, just come to this picture, download plot as PNG. So once you click it, it's automatically downloaded. All right. So you just see it like this. So it just goes into your download file here. All right. So you have this. So you can see it in your download file since it was downloaded. So I can just click here and just go to download and you find it right there. Okay. Or you can just also direct it to save in the folder you're working with. You can do that too. Okay, so we go back here. All right. So now that's one way to save. You can, in fact, that's the easiest to just click here and save as PNG. Then you can save as HTML too. So I'm doing the gauge chart. I'm saving as so this gauge chart now I'm saving it as HTML. So this saves an interactive HTML file you can open in a browser. So if I'm looking for this now, I just go straight to, I go into the folder I'm working with. It's on the desktop in maths with AJD, data analysis with Python. So then I just go for that gauge chart, tips percentage. So you can see it's in like web format. So, and this is it right here. Beautiful, beautiful. Gives the overall tip percentage in that eating place, so to speak. All right. So I come back to this. So you can also save it in JSON for reuse. Like so JSON, of course, you know JSON is like that thing you have in Notepad. You can save it in JSON. How did we save this? Line 22 is the key thing here. So you do fig.write underscore HTML and use the file name and it automatically saves in your folder. Then to save as JSON, it's fig.write underscore JSON flight heatmap.json. If I press enter, so it's you have this, then again you can save it. You can first of all you can save as PNG here, all right, and then even this one you can save as PNG. Even this one you can save as PNG. But then since you have also saved it as JSON, you can find it as a JSON folder right here. So that's especially if you want to reuse the code maybe on a website or something you're doing. What did we call that? Now that's flight heat map in JSON. So it gives you this. You can open it in Notepad, for instance, and then you see all the code. Like it's only people that understand that will understand, right? That if you want to use it to maybe do stuff. So I mean, going back to the downloads again, right? So you see everything we have saved is here. So the gauge chart, you have this heat map and this other one. So those are the ways by which you save in Plotly. Isn't it interesting? I surely believe it is. So you save in JSON this way, all right? You save in HTML this way, and of course, you can always uh, come here and save as PNG, right? Like that. All right. So we come to the end of this video. Let me know how helpful this video is for you. And let me know if there's a topic you'd like me to teach, a problem you'd like me to solve. If there's the kind of data set you'd like me to work with, just you can feel free to let me know so I can get the data set and run some project on it. I mean, just to do some stuff on it, and that'll be sensible. So if you have subscribed to the channel, thank you. If you have not subscribed, you know you're missing a lot already. I don't want to continue missing, so subscribe right now. And hit the notification bell so you can always get alerted every time a new video is released. And don't forget to share this to share, to like and share with others so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.